Robot Talk is the podcast that sits down with roboticists from around the world and asks them the questions you always wanted answered. Like, what's the best robot hand? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and in today's episode, we're exploring the relationship between human and robot anatomy with a guest whose research spans everything from primate-inspired robot hands to designing smarter, safer machinery for construction sites. Before that, this is your regular reminder that you can contribute to the conversation by sending in questions for my future guests. I announce upcoming guests on social media and Patreon, so make sure you follow the podcast to find out what's coming up. You can submit questions on the website at robottalk.org, on Patreon at patreon.com/Claire Asher, or by replying to one of my guest announcements on social media at Robot Talk Pod. So, without further ado, it's time for me to introduce this week's guest. I recently had a really interesting discussion with Chapa Sirithunge from the University of Cambridge about what robots can teach us about human anatomy and vice versa. Today, I'm talking to Chapa Sirithunge, a postdoctoral research fellow in robotics at the University of Cambridge, focused on using robots to better understand human anatomy and behaviour. Hi Chapa, lovely to have you on the podcast.
Hi Claire, thanks for having me today.
So you've worked on a really wide variety of robotics projects. So to get us started, can you give us a little bit of an overview of your research and the kind of core themes that motivate you?
Sure. So my research focuses on using robots as proxies to understand the human design. Design in the sense it could be the body, it could be the cognition, and also the relationship between the cognition and the body, how the environment shapes the way we think, perceive, and act. So I work on robotic hands because hands are the biggest interface that we interact with the environment. Mm-hmm. So that plays an important role in shaping our intelligence. So hands play a major role in my research. And other than that, I also work on concepts such as pain, because there are reasons to study these particular pieces of human aspect that can reveal information about sensory motor coordination, our multimodal interactions, and then how to build robots that can be inspired using these special human traits, and how to simplify these concepts and build robots that can help us in daily life.
Mm-hmm. So you think that if you can make a robot that is inspired by these aspects of humans, then it will be better at interacting with us?
Exactly. Because if you look at humans, we look this way because we've been shaped over millions of years and interacting with different environments, doing different things at different stages of evolution. And we are looking at this modern design and build robots. But capability-wise, robots will struggle because our understanding about our history is limited. So I'm looking at how to make this simple so we can adapt it easily to robots.
Yeah, and I mean, it makes complete sense to me that you would be focused on hands. I know there's, a line of argument that says that the design of the human hand is one of the reasons we were able to kind of come to dominate our environment and populate the world in the way that we have.
Exactly. Hands are more than object manipulators, but it's also a social signal communicating something to the environment. So I started off my research there, and now it's expanded to different areas, such as understanding high-dimensional features such as pain.
So there was a project of yours exploring robot hands and different designs for robot hands that I thought was really cool. So you developed robot hands based on the human hand, a double-thumbed hand, and even one that was inspired by the eye, which for listeners who may not be familiar is just a wonderfully bizarre Madagascan primate with a really, really long middle finger, which they use to prise insect larvae out of tree trunks. So can you tell us a little bit more about this amazing project?
Sure. So this is a long-going conversation between University of Cambridge and EPFL Switzerland. And we've been discussing how to come up with an open parametric design for a hand, because we have loads of robotic hands out there. We wanted to come up with a general purpose hand without customizing a hand every time we need a robot to do something. And also we wanted to focus on versatility and performance at the same time. So we've been looking at how primates developed, because I've been studying primate research for a while to understand this. And if you look at ancient primates and also extinct ones, which are closer to humans like gorillas, they had very different hands from the past. Some of them had very fat thumb and short fingers, especially those who were walking on the ground. And if you look at those who were on top layers of trees and jungles, they had longer fingers and thin palms, for instance, because they were swinging onto branches, jumping from branch to branch.
Yeah.
So the role of their fingers were more prominent than the role of their palm. So depending on the set of tasks, we call it activity budget. What type of activities we prioritize that shapes our hands. So I've been looking at these for these different primates and then came up with this idea to generalize it for a robotic hand, and then we discuss how to apply it for our existing robotic hand designs. And then we came up with this design which has over 50 parameters that you can modify, customize.
Okay.
Based on what you customize, you will get a completely different design if you compare it with your own hand. So that's how we came up with this II hand and human hand as a middle ground. And then we also thought about a symmetric hand. What if you have a symmetric hand rather than having two hands? Maybe you can have just one hand that is symmetric. So we wanted to see how these different designs can help us in daily tasks or identify which task they are good at.
And why did you pick the II?
It was special because it has this flexible middle finger. I work on soft robotics a lot, so I understand how flexibility matters, especially for manipulating objects. Similar to our skin being flexible, and then we have bones inside covered with skin. So skin adds an additional layer of grasping. In addition to sensing, we also make use of our skin properties to understand objects better and grasp them better. So this primate, it's the only primate with a flexible design. So that was interesting for us to evaluate why only one finger is flexible and how it adds value to the set of activities it was doing. So we wanted to adopt that concept to our design and see how it works. But the original idea was to cover a range of designs. So we wanted to look at the past, inspired by the past. We wanted to look at our hands and also do a bit of futuristic designs, like looking at what future hand should look like. So we wanted to apply this across a big design scope, looking at past, millions of years ago, looking at present, and also future.
Sure. were there any particular features of the hand that you came away kind of thinking, oh, that's really useful for a particular task? What are your kind of take-homes from this research?
I'm not sure what features adds value to the set of tasks we are looking at. I think it's very task dependent.
Mm-hmm.
That's one reason we wanted this general purpose hand to serve all sorts of tasks. So one feature we were particularly interested in is nonlinear joints and simple actuation. For instance, we use 26 tendons to actuate the entire hand, and it's completely passive. So based on the different stiffnesses that you can adjust based on the tendons guiding through each finger, you can add different behaviors to the fingers, and you can modify it for each and every finger as well. So especially looking at II hand, it had a different finger, so not all the fingers behave equally. So this adjustability is important as well. So a lot of features. I cannot really say it's just one or two features, but many. And we wanted to keep it open so users can modify accordingly.
Yeah, that's really cool. It's so many different possibilities when you have that much kind of customization. So, like, zooming out a bit and talking about your research more generally, what do you think that robots can teach us about the human body and vice versa?
I think robots are not very capable at the moment. For certain tasks, they are very good, but if you compare it with human, they are not very capable at the moment. So I think they are good platforms to simplify our design. For instance, we have complex faces and we have humanoids that look perfectly like human. But behavior-wise, they might struggle, especially when it comes to, let's say, plumbing, for example. If they have to connect two tubes together and plaster it, then they might struggle because they lack the contact information and they struggle in confined spaces as well. So I think robots are good platforms to understand these complex scenarios and break it down to understandable pieces, because robots want it simplified and then they can understand and work around it. So we look at the nature and we build robots. We call it bioinspiration. But I think it's biosimplification. We look at the nature, we build something simple inspired by that. So this is important for robots.
Yeah. But that process of simplification is not trivial, because to simplify something and it still work, you really have to understand what are the core features that are kind of essential to achieve whatever it is that you're trying to achieve.
Yes, exactly. Humans are multimodal. So if we look at one trait, for example, face, it conveys a lot. It could be a communication channel. It could be an actuation mechanism as well. It senses something from the environment through the eyes. So it's all linked together. So it's important to understand these links and how to separate the links so robots can achieve one at a time, and then how to do the integration as well.
Right, yeah. And of course, there are some things that the human form has been designed for that robots don't need to do, like my nose breathes, but a robot doesn't need to breathe. So that part of the design can kind of be put to one side.
Exactly. That's something we're struggling with at the moment, how to separate these set of tasks that robots don't have to do and what they should be focusing on more. So drawing this line is really hard at the moment.
Yeah, I'm sure. So you're currently a Future Roads Fellow as part of the Digital Roads of the Future initiative at the University of Cambridge, where you're working on using robots and automation to improve safety on construction sites. So can you tell us a bit about this project?
Of course. So this is a fellowship program with around 6 million in budget. So in this program, we are looking at 5 different fields, digital twins, smart materials, data science, automation and robotics, and then sustainability solutions.
Okay.
And the funding comes from Marie Curie Fund and also a set of industries within the UK. So we are working in these different fields as fellows to provide solutions to improve the road infrastructure in the future.
Mm-hmm.
So I'm looking at robotic solutions, and the reason for this is that construction sites are the root cause for over 20% of worker fatalities in the UK. So that costs a lot of money to compensate for the losses. It could be human life, it could be equipment, compensation as insurance. So it's a lot of money that we lose every year. So we wanted to look at solutions to overcome this.
Yeah.
So as a fellow, I'm looking at the safety around machines. I'm looking at the human aspect, what workers prefer in terms of safety in the ground. For instance, if they are working around heavy machinery, sometimes operators cannot see the environment. Not having the proper awareness about the environment because of the complexity and uncertainties in the surrounding, it can cause damage to the workers around. So I'm looking at how to improve the workers' situation, operators' situation, and how to improve the machine safety as well.
Mm-hmm. And so can you give some examples of the kinds of technological solutions that can improve those problems?
I visited several industries and was talking to machine operators, workers, and their technical experts as well about the current solutions. It's more like there's a defined space around the machine that workers cannot move into when a machine is in action, because when the operator is inside the machine because of the moving parts of the machine and other things in the environment, it can occlude the line of sight. So it's important that people around pay attention to this and save themselves. So at the moment, there are safety boundaries and also human tracking systems installed within machines, outside machines, and also in the sites in different places. That's one way to protect workers. And they have wearables that they can use whenever they are approaching something dangerous. It can alarm them.
Okay.
Yeah, these are existing projects. And also there are projects looking at autonomous machines. So if you completely automate, let's say, an excavator, people don't have to be around it facilitating the task. They can just be inside the office or safe zone so they are not in the way. What I look at is to improve machinery that are in the field at the moment without building an autonomous excavator from scratch.
Yeah.
I'm looking at how to improve the existing system because it's not easy to move from the current system to completely automated construction environments. So I'm looking at how to install the minimum number of sensors. For instance, it could be a camera tracking a human. That can inform the machine, or especially moving parts of a machine. For instance, if you take an excavator, there is this front arm that moves around, which is the root cause for most of the accidents, because once it's moving around you, you can't really see beyond that very well. So I'm looking at how to integrate control algorithms that can inform the machine and the operator so it doesn't hit someone. It can still go very close to a human, but it doesn't hit the person. So it's more like having a virtual repellent between the machine and the human. So the idea is to bring the machine as close as possible to the human, but minimizing accidents.
Yeah, and I think, one solution to this would be just to have a bunch of cameras and all these camera feeds go into the operator, but then you kind of are just overwhelming them with information. So having an automated system that can detect a person and automatically stop makes a lot more sense, I think.
Exactly. Having a lot of information is not the case here. So I'm looking at how to minimize it and also how to use the existing properties, like where to install the camera in a heavy machine, or if it's the surrounding, where to install it for the best view, rather than having many cameras around it.
Yeah. So we had an audience question on this topic from Catherine on Mastodon. So Catherine says, there's a big push to train up apprentices to work in the construction industry to build houses in the UK. Will these apprentices need robotics and industrial automation skills to be successful? And what other skills are they likely to need?
Eventually they might, especially if they use techniques like drones. I think it's easier if you can integrate such technologies. Like it can provide a better picture of the area, the house you're working on, such like that. So I honestly don't think they will need an expertise on these technologies to use it, but maybe some sort of skill to handle them so they can make use of these technologies better.
Yeah.
And you're asking about additional skill set that they might need as well.
Yeah.
We are working a lot on simulations, training platforms. So maybe using these simulators could help workers as well. So at some point, they might be practicing their skills with a simulator instead of a real ground. So translating from the simulator to the real world platform could be a good skill as well.
Yeah. So, I mean, basically, if they have an opportunity to get some experience in these kinds of areas, whether that be simulation or interacting with drones, if that opportunity arises, then it's a good thing to take that. But it's not necessarily going to hold them back if they don't have that.
Yeah, I don't think it's a problem for them. It will rather simplify their task or collaborate with them. It's not replacement, but collaboration. So whatever they find dangerous to do, like exploring a tunnel that goes underground, which is at the moment a very dangerous task to send a human into these. So for these, we can get the help from robots to provide a better picture, to crawl into dangerous areas, so the human can be in the safe area and send a robot to the dangerous zones. And still they can work alongside the robot to get the task done.
Yeah. So, I mean, I've been really keen to cover robots in construction on the podcast, and I've struggled actually to find people who are working in this area, which kind of surprised me. Has that been your experience, that this is quite a sort of novel area of research? And if so, why do you think that is?
I think your observation is correct. It's a challenging environment for robots. So the applications we find our current robots can tackle is limited. So that's one reason we are not very successful in the field of construction. So robots are very delicate compared to the uncertainties and dynamics in a construction field. But robots like drones have been successful because they can take this aerial view without touching anything on the ground. They don't have to manipulate any objects in the environment or go through challenging surfaces, for instance.
Yeah.
They have been successful, but other robots, those who can walk around, they are struggling at the moment. That's my observation as well.
Well, I'm really glad that you and others on this program are working on this area, and I will be, keeping track of the project to see what comes out of it. Chapa, it's been great speaking to you today. I've been chatting to Chapa Sirithunge from the University of Cambridge. Thank you.
Thank you very much, Claire.
Thanks for listening. If you enjoy Robot Talk, please share the podcast, subscribe, and leave a review. And don't forget to join the Robot Talk community on Patreon if you'd like to support the podcast and get access to some awesome perks, including monthly bonus episodes, behind-the-scenes updates, merch discounts, and more. Visit patreon.com/Claire Asher and join the Robot Talk community today. Next week, I'm talking to Shimon Weitzen from the University of Oxford and Waymo about making driverless vehicles smarter. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk Season 6 is sponsored by the Hamlin Centre, Imperial College London.